Hi, everybody who's joining. Feel free to jump in the chat if you'd like and say hi and where you're from. A standard reminder, as always with us, that there we go, that if you are going to join in the chat and say hello, please make sure that your little bar reads, that is in the chat reads all panelists and attendees and not just all panelists. And then you should be able to talk to everybody who's there and not just Bryon and eventually Chris and I. So thanks everyone for joining so far. Hi, Brent. I've got us up on YouTube. We're just waiting for Chris to come back because he's been having some technical difficulties. And he's back. Except you're muted. Sorry, Chris. There you are.
There we go.
So welcome, everybody. Today we have, first of all, we're so excited to be back. It's been a month. We've had a nice little break, and we're going to have a couple more sessions of Insider's Guide before the holidays, and then we're going to start again. We're going to take a short break over the holidays as well, and then be back again in January. Today we are talking about meteors and meteor showers and meteorites. It is topical because today is the peak of the Leonids meteor shower. And we also have a guest with us today, Bryon Czarnik. I hope I actually didn't check to see if that was the right way to pronounce your name. Did I do it? Bryon is a member of Toronto Centre and is a bit of a meteorite fanatic, very excited about them. So he's going to tell us a little bit about how to find them, how to identify them, all that sort of stuff. Though we are starting today with Chris telling us what's going to be happening in the next couple of weeks, what's exciting, and in general, a little bit of information about meteor showers. So Chris, over to you.
Terrific. Let me just share my screen here. So I just thought before we dive into the meteor showers that we'll just preview a little bit about what's going on in the sky these days. So if you head out in the evening on the next clear night this week, you're going to see the moon shining nicely in the western sky after sunset. And of course, this is the perfect month of the perfect week of the lunar month to get out there and use your binoculars or your telescope on the moon, because what's happening is that the moon is conveniently located after dinner in the sky, and also the sun is rising over the moon's surface, and that means that it's in a waxing. Its phase is waxing, starting out with a thin crescent. This evening, I've got the sky here tonight at 5 p.m. So it won't be up in the sky too long. By about 7 o'clock, it's gone. But every night it lingers later and later, every night this week while it waxes fuller and fuller. So if you were able to stand on the moon along the boundary line between the lit and the dark hemispheres of the moon, that you'd be seeing the sun just peeking above the horizon along that zone. And that means that the sunlight that's landing there is arriving horizontally, just like a sunset or a sunrise on Earth casts long, deep shadows. Because the moon has no atmosphere, the shadows cast on the moon are deep, rich black. So the sun brightly illuminates all the crater rims, mountain peaks, and so on, and it then hides the deep shadows. So it's a spectacular time to look at the moon all this week as it waxes from recently new towards its first quarter phase on this weekend. So if I just advance by a couple of days here, you can see the moon waxing fuller every night. So definitely dust off your telescope and binoculars and check out the moon tonight or any night this week. And what's really neat is if you watch the moon on a few consecutive nights, you can actually see as the sun rises higher over the lunar surface, you can see craters that begin with the dark bottoms, and maybe the central mountain in the crater has a little bright peak because it's in the sunlight. But as the days wear on, that crater will fill with light, and eventually the entire crater will be filled. There's a neat one called Theophilus, which is this sort of prominent one with the mountain in the middle of it that's just below the moon's equator. So that's a good one to use that practice on. So as I said, we're back here in the crescent, but a few nights from now, that'll start being filled with light. And so then we get to first quarter, and by the weekend, we're getting past that. And in the meantime, I'm sure everybody's been checking out the planets. Thankfully, they're still around for us. So let me just bring us back.
Mars has still been beautiful for anybody who's out these days. I've found great pleasure in going for nighttime walks, even though I'm deep in the city. And it's just so nice to see Mars so high up in the sky.
Yeah, it's actually, now that we're getting into November, Mars is actually climbing higher in the sky at night, which makes it even even prettier and nicer for viewing in telescopes. It's not as big and bright as it was during opposition a month ago, but it's still, still in that range of we're looking at. Mars has been running retrograde while Earth passes Mars on the inside track of the solar system, and that ended a day or so ago. And so now Earth and Mars are going to start more rapidly increasing their distance from one another, and Mars will start diminishing in brightness and in size in your telescopes. But it'll hang around in the sky as a little dim red star-like object until I think May. So it'll be around all wintertime. It just won't be as big and bright as it was. But the thing to look for when you get out right after dinner, not aside from the moon, are Jupiter and Saturn. So Jupiter is about 12 times brighter than Saturn right now. So that means Jupiter will pop into view before the sky is fully dark. And then you can look for Saturn sitting, a number of finger widths to the upper left of Jupiter. You can even kind of cheat and get the binoculars out and probably pick out Saturn using Jupiter even before Saturn's visible to the unaided eye, doing it that way. Now, Jupiter is closer to us than Saturn is, and so it's faster in its orbit, and that means that it's actually chasing Saturn down. And the big event of December will be the night when the nights around December 21st, which is the solstice, when Jupiter and Saturn will be in the same direction, which means that they'll practically look like one bright planet shining in the sky. I can preview that here. Let me just put Jupiter in the middle. We've done this a couple of times, but here you go. A month from now, they're going to be really close together. And then a few nights after that, they'll be practically on top of each other. And that means that they'll both be visible in a telescope at the same time, in the same eyepiece. So that'll be amazing. That doesn't happen very often. I think it's probably hundreds of years before it happens again.
It was the last time.
We're all hoping to see. Yeah.
The last time that it happened, if those of you are curious, it's in the Observer's Handbook. The last time that they were this close was 1623. Bearing in mind that telescopes were only invented in 1609 and 1610. Those were Galileo's first two telescopes. So it's been a while, and I mean, it may have been pretty close since then, but this is still very, very exciting.
Yeah. And don't fret if it's bad if it's cloudy on the night of the solstice, because even a few nights before, a few nights after, they'll still be relatively close together and visible in telescopes together. So you can pick up that. Let's just go back to tonight.
And while you go back, I'll also add that you'll want to have a good view southwest, because they're going to be very close to the horizon. So
that's right. They'll be low in the southwest. So
if you
sort of plan ahead.
Yeah, if you happen to have mountains available that you can stand on top of and face southwest, that's ideal. But if not, even something like if you're near Toronto, if you're looking southwest over the lake, that works out well too.
Yeah, and so as Jenna mentioned, we've got Mars shining in the southern half of the sky after dusk. It's crosses the sky over during the night and will set in the west in the wee hours around 3 or 4 a.m. in the morning. So definitely take a look at it if you have your telescope. You can still see some cool markings on the planet. I think this week we've got, oops, let me just pull this back a little bit. So you can see these dark features that are the sort of exposed basaltic rock on the planet, and the brighter areas are the dust and sand covered regions on the planet. So you might be able to pick that out if your telescope is not too bad. And then the last big thing planet-wise, we've got Uranus and Neptune up there as well. They're a little bit hard to see without help. So if you've got an astronomy app, or you want to check out my skylights, usually put in detailed sky chart for finding Uranus and Neptune in the evening sky. But then if you're an early riser, so let's just pop this into the morning sky. So we've still got Mercury visible this week. So Mercury reached its maximum angle from the sun a few days ago, and it's now starting to sink down every morning a little bit. But for the next few mornings, you should be able to pick up Mercury if you have a nice open and low east and southeastern horizon with no clouds in the way, because it won't cut through the clouds very well if you've got clouds. But check the weather forecast. If it says it's going to be a clear morning, bundle up and head outside, take a look. And then you've got Venus shining brightly right above it. And you can check out Venus. If you want to see the solar system in motion, pay attention to Venus sitting just to the left here of this bright star Spica, And every morning, Venus is going to drop compared to the stars. So you're seeing Venus's orbital motion, moving it through the stars. All right, so let's put this away and we'll switch back to meteor showers. So meteor showers, for talking about meteor showers, you've got to talk about comets, because comets are the source of the particles that produce the streaks in the sky that we see as meteors. Bryan's going to talk a little bit later about meteorites, which is a different kettle of fish, and we'll get into that a little bit later. So what happens basically is the Earth is orbiting the sun on an annual basis, around the sun once every year. And that means that the Earth lands at the same place in the solar system relative to the sun on the same date every year. And if you get a comet traveling through the solar system, I've got a 3D model of the solar system here. We've got the plane of the solar system showing these colored orbits. So we've got Earth being the green one here, Mars being the brown one, Mercury and Venus being the internal ones. And then this light blue orbit, that's Halley's Comet. And you can see that Halley's Comet is a periodic comet. It cycles through the solar system on a period of about 80 or so years. The last time it visited was 1986. And as these comets travel through the solar system, when they get nearer to the sun, they develop their tail, they begin to outgas and emit the dust. They drop that material in their wake. And the comet's orbit then gets a collection of these small particles in the trail of the comet's orbit. And those particles might be dust size or even as much as a gram or two. They can be, the size of a grain of sand. Sometimes they can be a little bit bigger. But they accumulate and they spread out. And as the comet repeatedly cycles on its orbit year after year over hundreds and thousands of years, that material accumulates and it develops into these long sort of tube-like clouds in the sky. And you can see that if I bring the solar system top down here, that Earth's orbit in green actually crosses not far from Halley's Comet's orbit in two places. So once here and once over here. And we can talk about, so that means that Halley's Comet is actually responsible for a couple of our annual meteor showers. Now, as I said, because the Earth ends up in the same location every year, that means the meteor showers, which are the particles being captured by Earth's gravity and then plummeting to the Earth, happen around the same dates every year. So they're annual events. Now, everything that in space, happens really fast. We're not used to the speed that things happen here on Earth. So when these particles get captured by Earth's gravity and they fall to Earth's surface, they're traveling at speeds of 40,000 to 250,000 kilometers an hour, much faster than we're used to, rifle bullets and things like that. And that speed that they're traveling, when they hit the Earth's atmosphere, they're basically tunneling a hollow through the molecules of Earth's atmosphere, and the kinetic energy is releasing heat as friction. And that heat ionizes the atoms and molecules in the Earth's atmosphere, and it's that ionized glow that we see as the streak, producing the shooting star effect or the meteor effect. And those tubes could be, say, a meter in diameter, but many kilometers in length before the energy dissipates enough for the effect to stop. Now, the word meteor is similar to the word meteorology. And that's because meteors are actually happening in Earth's atmosphere. So they're happening about 80 or 100 kilometers above the Earth's surface. They have absolutely nothing to do with the stars beyond. So people call them shooting stars because of the way they look, but not because they're connected at all to the stars. I did a talk once at a library, and one of the questions at the end was, after a meteor shower, will the constellations be different? Because they thought that the actual stars that make the constellations might have been falling to the Earth and changing the way the sky looks. Well, that's not at all true. The shooting star is just a nickname that has nothing to do with deep space. Now, occasionally we can see a little bit of color in these meteors, and That's mainly due to the ionizing of the atoms and molecules in the atmosphere. So you can get, reds and greens and blues, the sort of colors that we see in the aurora borealis, because it's kind of a similar effect. We're ionizing the content of the Earth's atmosphere. But at the same time, the particles themselves can be burned up, essentially, or dissipated or used up as they, through all this heating and so on. And so the mineral content in the dust grains can also give off some color. It's a bit like taking filings and burning them in the candle flame. You can get these different colored effects. Maybe you had a chemistry set at one point or did an experiment in school where you were able to take different elements and burn them in a flame or you can get oranges and purples and other colors that are produced when the minerals vaporize. And astronomers can actually analyze the colors produced by these meteor trails and determine the chemical composition of the meteor particles. Any questions so far?
I have one.
Yeah.
No one from the chat, but I was just curious if folks are analyzing the trails, are they capturing them in photos? Are they just keeping an eye out and looking for them? How do they get like the color?
Yeah, you would have to put a diffraction grating on your camera and then analyze the colored streaks after the fact. Yeah. We'll come to that a bit later. It's really not helpful to use binoculars or telescopes on meteors because the odds of you actually capturing the event, such a quick event, in your limited field of view is so high, so difficult, right?
Mm-hmm. There was just a quick question from Graham, and I wanted to mention he was saying that they presume telescope is needed for Uranus and Neptune, are binoculars needed for Mercury. Just to let you know, Graham, that Bryon and I are answering your questions in the chat. But essentially, you don't need binoculars for Mercury, but they might help, especially if it's close to the horizon. And some people have claimed to see Uranus and Neptune naked eye. I'm not sure if that's actually technically possible, but
yeah, if you have a very dark moonless sky, it's possible if you know where to look. This week, not so much because the moon will be sitting there in the evening sky, not far from those planets. Make sure if you're using binoculars on Mercury, though, that you put the binoculars away before sunrise. Really important.
Yeah, don't look at the sun with anything. Your eyes, binoculars, telescopes, unless you have the right filters. But generally speaking, don't look at the sun. Okay, back to you, Chris.
Good questions. Yeah, I'll pause every now and again so we can field some of these questions. So the meteor showers typically run for a number of days or hours, depending on the shower. And what influences that is how long is it taking the Earth to pass through that debris field, and whether or not the Earth is tunneling through the middle of the debris field or maybe skimming the edge of it. So if we just sort of hitting the very edge of it, we may only get meteors for a very short time. Whereas if we're traversing the whole width of it, we'll get meteors perhaps over many, many days. And the other factor is the geometry. Are we passing the shower at right angles, or are we doing it obliquely, which makes the trip longer? It's a bit like, wading across a stream straight across, or if you walk downstream, you're going to be in the water longer, right? But you may need to do that if you're fighting the current. So there's that factor that runs into how long the showers last. And then basically what happens is that as we first encounter the cloud, we'll get a few meteors happening in the sky. And then the number of meteors will ramp up over the ensuing days until we're passing through the densest part of the field. So that will be called the peak night. So when you hear on the news or the weather network that the certain meteor shower is peaking, that means that the Earth is now traversing the middle of the cloud or the densest part of the cloud. And after that night, the meteor shower doesn't come to an end. It just now tapers off again. So it ramps up, peaks, and then tapers off again. I'm going to show you a cool diagram that our friend Blake Nancaro made, where he mapped how many meteors are expected versus date for the showers that are coming up. The reason that we picked meteor showers to do this topic at this time of the year is that we're in a period of time now over the next couple of months into January, we're going to get a wave of a number of different meteor showers coming. So it's a good time to know what they're all about. All right. Now, the other thing that happens is that the comets are dropping these particles and the comets are orbiting the sun, but so are the particles. So the density of the field can vary according to how when they were deposited and how they're managing their trip around the sun. So from one year to the next, we could arrive at the same debris cloud, but we could be passing through, a thinner, less dense part because the sort of a clump of them have moved away and we're not passing through that particular more dense clump. So meteor showers will vary from year to year. And actually the astronomers and planetary scientists, they run computer models that look at the geometry of everything and past historical, reports on meteor showers. And they use those to predict how the showers will be in a given year. And it does vary from year to year. It's not an easy process. There have been times where it's been all over the media that there's going to be a meteor storm. Meteor shower is going to be more intense than usual. And a number of us will go out, find a nice place to look at meteors, and then we won't see hardly any because the model just didn't work as planned.
Interesting. It's creating hypotheses and then testing them basically.
Yeah, I mean, the statistically, sometimes they win and sometimes they're off a bit. They don't. But it's all a learning process.
Mm-hmm. There's a question here from, I believe, Christina. Do astronauts ever see meteor showers in space? Which is a really cool question, and I have no idea. I guess so, huh? They might see
I would say that, well, they wouldn't see them above them. They would only see them in the Earth's atmosphere.
Yeah.
So they would need to be looking down at night, and I don't see why they couldn't. Bryon, have you ever heard of such a thing?
I actually have a picture of a Perseid meteor that they took a picture of it from the space station.
Oh,
so,
wow.
Yes, you can see them.
Very cool.
Down below.
That's very cool.
Okay, so the style of the meteor shower can also vary according to the type of particle that's in the cloud, the type of material that's been dropped by the comet. So if the comet has dropped larger, more rubbly sort of bits and pieces, then we can get much more strong, intense meteors. Sometimes we can get something we call fireballs, where the meteor will shoot across the sky, but it'll break apart and it'll sort of spit off almost what looks like sparks. So you want to make note of that. The Meteorites meteor shower that was a week or so ago, or a couple of weeks ago, they're known for being more of this sort of fireball type. And again, this is all part of, the different considerations when we're talking about which meteors are coming up. So what's happening? So, sorry?
Can I jump in with a question?
Yeah.
Okay, so this is a question from Pierre. Is the speed of the meteors due to the speed of the comet, or I suppose the debris that it's left behind? Or is it affected by solar wind, or maybe the atmosphere, or possibly gravity? Is it more the comet falling to Earth, or is it more the debris falling to Earth, or is it the debris speeding along on Earth getting in the way?
It's a bit of both. It's really to do with the fact that the speed in the material orbiting the sun in its orbit is a lot different from the speed of Earth in its orbit. And you have a delta V. You might have heard the expression delta V, and that's where you need to match the velocities of two orbiting bodies in order to rendezvous with them. And so we're not at all in the same orbit as the cometary materials. So when we encounter one another, we're moving at vastly different speeds. And so there's that. Plus, then there's also the gravity of Earth pulling the material down. But really, it's more the speed difference in the two orbital amounts. That's the biggest consideration.
Thank you.
Yeah, that's why the things like Chelyabinsk, came out of nowhere so rapidly, because it was moving so quickly compared to Earth's speed. So
that in that case, that was more to do with less to do with the Earth pulling it in and more to do with how fast the bit was moving, or the meteor was moving.
Yes. Yeah. So when we're looking at meteors in the sky, what's happening is that the Earth is plowing into this cloud of debris, and you can think of it as a bit like bugs hitting the windshield of a moving car, right? So the Earth is traveling around the sun in its orbit, and as we move sort of tangentially across in our orbit, then we hit these clouds of debris. They're hitting the Earth's the sky above us. And the direction that the Earth is traveling in space, because the Earth is constantly driving in a circle all around the sun. So we're actually looking at different constellations as we head around the sun. So the sky overhead, when the sky overhead is aimed into the debris field, that's when you're going to see the most meteors. And that typically is before dawn, because when you think about it, if the sun is rising in the east, then it means the direction towards the sun is that way, and we're moving at right angles to the sun. So we're actually heading straight up. So the Earth is moving straight up when the sun is rising. And so the direction of Earth is up, and our windshield is driving up into the sky. And that's when the meteors are going to be more intense, is when they're coming from above and crossing the entire available span of the sky, if you like. Now, the place that...
Oh, sorry, I have one last question, if you don't mind me asking one last question. It's from YouTube. Do comets crash together when there are so many comets going around the sun? Or possibly even not voiced in the question, but I'm going to add it, does the debris crash together?
I've looked at YouTube videos of time lapses of the sun's neighborhood showing comets coming in and animations. I think it would be very unlikely or very rare for two comets to arrive at the same time or to be interfering with each other. Comets can break up and sort of move as a group. Their pieces can move as a group, but no, I don't think we've ever seen two comets collide or anything like that. Yeah, interesting question though.
Yeah,
doesn't mean it won't happen one day. It just hasn't happened yet.
Yeah, the odds are low, but not zero.
That's right. All right, so when the Earth's windshield is above our heads, heading into space, the constellation or the stars that are in that patch of the sky give the meteor shower its name. So for example, when in the summer, when we're in the Leonids meteor shower tonight, that means that the constellation of Leo, the lion, is roughly the direction the Earth is traveling towards before dawn. And so the meteors seem to be coming from Leo, the constellation Leo. That's why they're called the Leonid meteors. But again, they have absolutely nothing to do with the stars in Leo. They're happening just in our atmosphere. And Leo stars are unimaginably much farther away. They're just completely different. It's just a way of giving us kind of a naming system for the meteor showers. All right, so when should you look at meteors? So the idea is that you want that radiant, that area where the meteors appear to be coming from, to be as high above the horizon as you can get. And that's because when the radiant is low, the meteors that are heading down, they're hidden by the Earth. So you see fewer of the meteors. If the radiant is nice and high, then you're seeing them all over the sky. So you're getting a higher number of meteors visible in the sky when the radiant is up high. Typically, as I said, that's before dawn, but not all meteor showers have their radiance high up in the sky before dawn. Some of them, the ones that were sort of hitting a glancing blow, the geometry isn't quite the same. And so some of them are best in the late evening. Some of them are best around midnight. They vary one from the other. We can talk about a few of the different ones later on. Generally, when we're having a meteor shower, the whole world is experiencing the shower, unless the constellation, the radiant, is far to the north or far to the south in the sky. So if the constellation's radiant, if the meteor shower's radiant is up in the vicinity of the North Celestial Pole, then that meteor shower will be favored by Northern Hemisphere people and not so lucky for people in the Southern Hemisphere, and vice versa. So there are ones that are great for them that we don't get up here in Canada. There's one called the Quarantids. That's up near sort of the Big Dipper Draco area. And that's a more northerly shower that is better for Canada, not so good for the Southern Hemisphere. Now, the timing of when we're passing through the maximum amount of the meteor debris, the particle debris, has nothing to do with the time of day on Earth, right? So it happens that we're going to pass through the maximum cloud of the Leonid meteor shower around 6 p.m. today. But we're not going to be able to see any meteors at 6 p.m. necessarily, because the radiant isn't even above the horizon for us at that time. But it is for somebody on Earth. So the lucky gang who are sitting on Earth where the radiant is high at our local time, 6 p.m. So for them, it'll be perhaps in the dawn, at pre-dawn, 6 a.m. if they're halfway around the world. So that makes meteor showers a little bit more tricky when they'll say the meteor shower is peaking at a certain time, but really the best time to look for it is a different time from that, because you want to get that radiant in your sky. So because the Leonids are peaking this evening at dinner time in Canada, we're in the Eastern time zone, the best time to look for the Leonids still was, or so the next best option for us would have been this morning before dawn, or maybe late tonight and tomorrow morning before dawn. So we're not in the densest part of the cloud, but we're still near to it. So we're still getting a good number. Now, the last little bit of jargon I'm going to give you is something called the zenith hourly rate. So the zenith means directly overhead, and the hourly rate is how many meters per hour. So you'll hear people say, this shower is typically known to deliver 15 or 20 meteors per hour. And that means that you're going to get one every few minutes on average. You might get two at once and then have a wait. But on average, it's about 10 or 20 per hour. I'll go through what some of the typical meteor shower rates are in a couple of minutes. We have some showers that are 10 or 20. We have a few showers that we get every year where the zenith hourly rate is over 100, and that's almost 2 meters a minute. So that's great. And again, it can vary up and down. Now the final big factor in all of this is the moon. So let me get rid of this, and I'm just going to bring up Stellarium again here and talk about the moon. So as we mentioned at the top of the session, the moon is a nice waxing crescent, and it's setting soon after the sun this evening. And that means that if we want to look at Leonid meteors in the pre-dawn sky, there's no moon around. And the moon is, aside from clouds, the moon is the biggest obstacle to seeing more meteors, because the bright moonlight will overwhelm the dimmer meteors. And so if you want, on any given year, the moon could cooperate with us or not cooperate with us. So a really fantastic shower like the Perseid meteor shower, we may have one year where we have a new moon, where there's no moon in the sky at all, and we get lots of meteors. Another year, we'll get a full moon, spoiling our show. So I'll talk a little bit more of that in a minute. And again, the phase of the moon is on a completely different cycle from the Earth's orbit around the sun. So it's always going to be a different phase of the moon every year when a meteor shower comes around. Questions on any of that before I get into viewing tips?
No, I think we're okay. There is one question about comets in general, and less so meteor showers. Would you like to take that now or later?
Yeah, we have a minute, sure.
Okay. This is from Joe, who asked if do all comets in the solar system eventually get sucked into the sun, or can they escape gravitational pull? Bryon added that some do fall into the sun. And Joe expanded, saying, if a comet continues to lose mass as it orbits the sun, isn't there a critical comet mass or momentum below which the sun's gravity could devour it? So we're getting into stuff that I have no idea about, and if I don't know how to summarize particularly well, I'm afraid.
Yeah, I don't have all the facts and figures at my disposal on my fingertips, but yes, it's true that some comets, they fall in from the outer solar system, and their trajectory takes them too close to the sun to escape, and they get swallowed up by the sun, or maybe too close and they burn up. Other comets fall in, and they're lucky enough that they don't get too close to get pulled in, but they actually get their orbit deflected and go into permanent orbit around the sun. So those are called periodic comets. And if you look at comet names, you'll see things like 51P. In other words, 67P Churyumov-Gerasimenko was the comet that the Philae lander landed on, the Rosetta mission. So that P means it's periodic. It cycles the sun. It shuttles in and out of the solar system on a time scale. I don't happen to remember its orbit period, but it never really goes away. It'll continue to do that forever until something disrupts it, which is unlikely. And it will, as it gets near the sun each time, it'll give off some of its gas and dust, and it'll gradually decrease in mass, and that can also change its orbit slightly over time. But really, you're talking, I mean, I think you're talking billions of years before you'd be likely for a comet like Halley's Comet, which is, by the way, is number 1P, because it was the first confirmed periodic comet, before it would lose enough mass for that ever to happen. So effectively, they're almost forever orbiting the sun. And I'm not sure if we've picked up, I guess every now and again we do pick up, we add new periodic comets to the roster as they fall in. And so, you know, the population of comets that are traveling through the interplanetary solar system will probably grow a little bit over time as more of them get captured. But yeah, basically that's how that works.
Cool. And then one last quick question, which I swear will be quick. Do comets gain mass? I don't think so, right? Unless they like run into something.
Their gravity is pretty small. I mean, there is a lot of particulate debris, interplanetary dust, and so on, and junk kind of floating in the solar system. And they could kind of grab that as they pass by. But I think their net would be to drop more than they pick up.
Fair. And I think, and Cicely added a further question to that, which was more or less answered, which is how common is it for foreign particles or debris to join a comet's orbit? And I don't know if anyone's really ever been able to measure that.
Yeah, well, I mean, eventually when humans become, you know, spacefaring on a regular basis, and we're traveling around and visiting different comets and things, and perhaps mining them, we'll start collecting isotopic measurements on the chemical fingerprint of various asteroids and comets, and we may discover, oh, this piece that I picked up here actually came from another object.
Yeah.
It's alien. Just as we get meteorites landing on Earth, as Bryon will mention, I mean, bits of things can land on other things.
Yeah. And the thing is, we can't really tell until we actually go and look at it a lot of the time.
Yeah.
And we have never visited a comet. We only just recently visited an asteroid. Wait, 67P is a comet, right?
67P is a comet.
So then we did. I lied. But I'm
and
not sure
we've had flybys, but we've never landed before.
Right. We've only landed on an asteroid.
All right, so let's talk about my tips for getting the best meteor show. So first of all, clouds will spoil the party. So you don't want to plan your expedition if it's going to be cloudy. So you need a clear night. Find out what the moon is up to, because that could dictate when you want to look. If the moon is going to be rising in the morning or visible in the morning sky, maybe you want to look for the meteors in the evening. And I should have mentioned that even though the radiant of a meteor shower is at its best in the pre-dawn, you can still look for those meteors as soon as it gets dark in the evening before. So you won't get as many, but you'll still see some. And so it's not necessary to just only get up before dawn and see the meteors once a shower is underway. So figure out what the clouds are going to be doing, what the moon's going to be doing. You can do that by watching the Weather Network. You can read my skylights every week, where I'll mention when a shower is occurring and what the prospects are, and do some things like that. Now, when you're ready to do your observing, then you want to find a safe, dark sky place with lots of open sky. So a rural location, or maybe a provincial park or a conservation area. You want to make sure that it's safe and that you've got companions and that people know where you're going, all of the usual important caveats about that. Of course, we're also observing social distancing right now, and travel restrictions that may be in effect for your municipality or your city. But let's assume we're past the COVID and we're ready to do our meteor shower watching. So you want to bundle up, make sure you've got warm clothes. You want to find a place that's got the minimum of artificial lights. You've got a nice dark sky, and you try to avoid trees, buildings. You want to get as much sky, because that's your window of opportunity. So the more sky you've got open, the more opportunity you have to see meteors, because they can really happen anywhere in the sky. You might want a chaise, you might want a blanket that you can just lay down and look up, or a recliner that you can sort of lean back and look up. Don't bother finding where the radiant is and staring at it. And that's because the meteors that are coming from that direction are heading towards you. And so they'll have really stubby tails, if none at all. You want to get the ones that are away from the radiant that are streaking across the sky. Sometimes the off-peak hours for the meteor showers are great because you get the particles that are skipping across the top of the Earth's atmosphere and producing really long streaks. Let's see, if you see a meteor, you want to point in the general direction and shout, let your companions know. But by then it'll be too late if they were looking the other way. But what you might notice is you might get a little smoke trail that dissipates over or a few seconds or even a couple of minutes if it was a fireball. So you can get that happening as well. So see if you can see the dissipating sort of smoke that's coming through. Keep your phone out of sight. You don't want your bright screen ruining your dark adaptation. Turn off your notifications if you can. Turn your screen brightness down. Maybe put some red film over your phone. If you've got friends with you, don't look at them in the eye and chat with them. Chat with them while you're looking up, because otherwise you're going to miss the meteors. And if you're looking at them while they're looking up, they're going to see it and you're not going to see it. You're going to be jealous. So that's a tip.
Life hack: ignore your friends so you can see more meteors.
Yeah, they'll understand. Hey, that's what you're there for. Now, you can go out on any given night and you might see one or two meteors that are called sporadic meteors. They're not part of a shower. They're just a particle that's gotten captured by Earth's atmosphere and shoot across the sky. So don't be surprised if you can see a meteor on any given night you're out, maybe even a few if you're out for a few hours. And they're called sporadic. That's the name for that. Last couple things. As I said, you can bring your binoculars and your telescope to look at stuff, but while you're watching for meteors, put them away, because the field of view is such a narrow patch of sky that you're likely going to be looking in the wrong place when the meteor happens. So I don't usually recommend binoculars or meteors for the showers. Let's see, anything else? I think that was it. Now, somebody might ask about photographing meteor showers. I haven't done it personally, but I'm going to share with you a page here that you can go to. Let's do this. I'll bring this across. So this is a website called the American Meteor Society. Under their Meteors tab, they have how to photograph meteors with a DSLR. And you can find that. And we can actually share that link in the show notes a bit later on. But it has all the information about what you want to, best practices are. Rule of thumb, though, basically they said something to the effect that you want between about a 10 and 25 second exposure. You want to use ISO 400 to 800, and your lens should be set to about f2.8 or so. So you want a nice wide field of the sky. And then you want to take frame after frame after frame after frame after frame, and then see which ones you got lucky and got meteors on. So you could, if you've got a battery pack for your camera, set it on your tripod and set it up with an interferometer or something that'll automatically continue to take pictures. You might collect 300 or 400 or 500 pictures in a number of hours overnight, and then go through them and see what you've got in the way of meteors. You can even sometimes stack them together and produce some of the effects, like the one that's behind me. That picture that's behind my shoulders is a series of meteors that have been composited together. All right, let me show you this cool graph that I was talking about before. I'll open this up and bring this in. So what Blake did a number of years ago is he looked at the different showers through the year. He looked at how many the zenith hourly rate peaked at, and he looked at when the showers began and when they end. And we worked a bit together on this, and we talked about kind of a formula for how it would ramp up and how it would ramp down. And he's gone through a number of iterations. And you can see that sort of in the October, November, December range, there's a whole wave of meteor showers that happen one after the other. They even overlap. You can see that some of these overlap. So we have the Taurids here in green. The orange ones are the Taurids again, and the Leonids should be the yellow ones, I think, or the white ones. Leonids are the white ones. And then there's a few others in here as well. The big peak up here is the Geminids, which are coming up. I'll talk a bit more about that in a minute. You can get more information about meteors in the Observer's Handbook of RASC. You can, again, watch my skylights, and you can go to the AMS Meteors website. Jenna, do you have any other questions?
So far, there was one question quickly about Mars, but I believe, Bryon, you've answered it satisfactorily. It was just how to, I will leave that to you, Bryon, to talk about anyway. So we are then officially good on questions. I've sent out the link to that AMS Meteors article that Chris brought up in the chat and on YouTube. So it's around if you want to click on it.
So the Leonids, just to sort of wrap up our story about the Leonids are going to continue until December 3rd, but by then they'll be tapered off to next to zero. So tonight is a good night to look at Leonids, but again, any night, any next clear night that you get out, you're going to see fewer of them, but there'll still be some happening. And again, if you can get out before dawn, that's the best, but you can start looking for them while you're out walking the dog after dinner, once it's dark, anything like that, anytime you're outside on a clear night. The next big shower that's going to peak is on December 14th. That's the Geminids, as I mentioned, with the nice big peak. Let me just set that to December 14th. If you're using Stellarium, by the way, you can configure it to show the radiance in the sky. So here's the different radiance labeled here as well. Here's the Geminids radiant up here near the top of the constellation of Gemini. And I'll just pull this back a little bit. And you can see the Z here is the zenith, so that's straight overhead. And so if the Geminid radiant is getting closer to the zenith, then you're getting that full sky available to you. And as I advance later in the evening, you can see by after midnight, the radiant is getting closer to the zenith. So that's sort of a nice middle of the night meteor shower. That starts on December 4th to the 16th, roughly. And again, you can start looking for them in the evening, but the best time will be after midnight. These ones are often bright, intensely colored. They're slower moving because they're not produced by comets. They're produced by an asteroid that dropped bits called asteroid 3200 Phaeton. Let's see. So yeah, that's one to watch out for in December. Then we get one called the Ursids as well in December. That's going to peak around the 22nd. By the way, the Geminids will have a new moon, so there's no moon in the sky at all for that. So it'll be fantastic for meteor shower watching. Let's see, do we have the Ursids meteor shower in late December? And then we have the Quarantid shower. So the Quarantid shower, which happens between December 30th and January 12th, is going to peak on January 3rd. And that one produces up to 50 to 100 meteors per hour at the peak. The Quarantids are named, I said that meteor showers were named after constellations. There is no constellation called Quarantid, which means the mural quadrant. That's because that constellation got replaced. Let me just bring up the night sky for the January 12th here, January 3rd. So there's the Quadrantids. It sits up here between Draco and Bootes, kind of down near the Little Dipper. And it gets highest in the sky, again, just before dawn. And that one is going to have a fairly bright moon that night. So it's not really going to be one to make a special effort for. And just skipping ahead into next summer, the Perseid meteor shower is the one many people have heard of. It happens on around August 12th, 13th every year. And on that one, we get up to 100 meteors per hour again at the peak. That one, next year, we're going to have a waxing crescent moon that sets early in the evening, leaving the rest of the night really good for meteors. So I can share some notes on some upcoming showers, but with that, I'm going to stop and I'm going to hand it over to Bryon. Unless there's any questions before I do that.
So far, we were good on questions, and Bryon can dive in and answer that question about Mars when appropriate and when it suits your presentation, Bryon.
Okay. All right. Let me just bring up the screen. And okay.
Nice.
Can you see
Fantastic.
that?
That's cool,
That's
yeah.
the Perseid meteor, and you can see one of the solar panels of the space station.
Wow.
So I'm going to talk about meteorites. I'll tell you where they came from, what are they, a bit about how to identify them, where to find them, and maybe some interesting ways of collecting them. So look at this painting for a minute. Imagine yourself an artist. Can you see the screen, guys?
We can see the screen, but we don't see a painting. We still see the Perseid's meteor.
Oh, okay. Now do you see the first slide?
Not yet. At least not for me.
You could try unsharing and then restarting.
Yeah,
this
resharing.
here.
Okay, let's try it again. Oh. Can
There
you
we
see it now?
There we go.
Good.
Okay. If you look at the painting on the right, imagine yourself as an artist looking at out of your window at this wonderful winter scene. And that's actually what was happening. All of a sudden, from over his shoulder, this bright light came, streaked across the sky with this huge trail of smoke. And in the woods, the forest, in the distance, it suddenly exploded as bright as the sun and with a deafening roar. This was the largest fall, most fascinating one of our modern decade in East Siberia near the Chinese border. And there's an example there's one meteorite from the 23 tons that fell in the woods. Some of it embedded in tree trunks like that, and some in several craters over a 1 kilometer area. They estimate that the original mass was about 100 tons. So it vaporized that much when it came to Earth. So meteorites have fascinated people for centuries. So let's just talk about what meteorites are. There's two things, a meteoroid and an asteroid. A meteoroid is a piece of cosmic debris or dust up to a meter wide. The kind of meteors that you see in a meteor shower, they're at most particles up to, say, the size of a pencil end, a pea. Over a meter, they're called an asteroid. And Chris mentioned very bright ones are called fireballs, and an exploding one, like on the first slide, is a bolide. Any that happen to get below, say, 50 kilometers altitude have a better chance of reaching Earth. And when they reach Earth, they're called meteorites. So let's look a little more closely at the path a meteoroid takes. So you see here a model, and when the meteoroid gets maybe 80, 100 kilometers up, at the speed it's traveling, it starts to vaporize, and that vaporized material heats up, and with the pressure, ionizes the oxygen and nitrogen in the atmosphere, and it generates the light Chris was talking about. This whole process is called ablation. Some melting occurs and gives color. For example, iron will give a yellow color to the meteor. and it rapidly decelerates in a matter of seconds. So in a matter of seconds, it gets down to a point maybe 15, 20, 25 kilometers in altitude. It's slowed down tremendously from, say, 30, 40 kilometers per second down to 2 to 4 kilometers a second. And that's slow enough that it's no longer undergoing ablation. So the light stops. So essentially, the meteoroid becomes invisible. And it enters this bottom phase here where it falls in dark flight. You can't see it. And that process, it slows down right to maybe 100 to 200 kilometers, 100 to 200 meters per second when it hits Earth. So let's talk a bit about some of the major events in history. Meteorites, they date from the formation of the solar system 4.5 billion years ago. They're older than any rocks you'll find on the surface of the Earth because weathering, erosion, geological processes like plate tectonics, where any of those old rocks Earth has. Oh, we all know about the dinosaurs disappearing. You can go to Meteor Crater, Barringer Meteor Crater in Arizona, east of Flagstaff. It's fantastic to see. You see a little ridge as you drive up, but it's 1 kilometer wide and 170 meters deep. And that was from a meteorite 50,000 years ago that was only 50 meters in diameter. I said meteorites played a big role in history. Humans all over the world would find these iron meteorites and use them to make tools and weapons way before we got into the Iron Age and they knew how to smelt iron ore and make iron weapons. In fact, in Tutankhamun's tomb, he was buried with a dagger that was made out of meteorite iron. And I've mentioned here on the first slide that Sikhote-Allen meteorite that fell. There's others like the famous one in Siberia that burst above the ground and flattened a huge area of the Siberian forest. Now, meteorites can be found everywhere, but in Antarctica, they discovered black rocks, dark rocks, which actually were meteorites. And it's interesting, it's not just a matter of the white snow or white ice, it's the flow of the ice. As it goes over the surface, it'll melt away. It collects the rocks, the meteorites, and it eventually, it might hit a surface and melt or leave some meteorites there. So it's become a good source of meteorites, but only government expeditions go there. Now, along the bottom here, recently we've sent expeditions to the moon and picked up lunar rocks. We've gone to Mars with rovers and orbitals and analyzed the surface and the atmosphere. And we've sent the Dawn spacecraft to the asteroid Vesta, the second largest, 500 kilometers in diameter. And from all that data, they're able to tell now that certain meteorites are from the moon, or they're from Mars, or they're from Vesta. In fact, 1 in 16, they believe, might be from Vesta. So that's very interesting, and there'll be much more learned as we get more spacecraft and more data, like the Bennu asteroid that was visited back in September. The last slide here is the Chelyabinsk meteorite superboloid that burst over Russia, injuring 1,000 people and creating a real boon of meteorites fragmented on the icy lake surface. Actually, 1 year later, during the Sochi Olympics, on the anniversary date, February 15th, all 10 athletes that won a gold medal got a gold medal with a portion of the Chelyabinsk meteorite embedded in it. So meteorites have played a role in history. But for scientists, they tell us a lot of things. So for instance, from the isotopes in meteorites, they can tell, for instance, the age and information about the age of the solar system. So for instance, I think it's potassium isotope 40 decays in billions of years to argon 40. So the relative proportions of those two help date the meteorite. They also are so ancient that they tell us something about star formation. And of course, something about the evolution of our solar system. And impact sites give us insight to how the Earth and the Moon were formed. And chemicals within meteorites are consistent with components of amino acids. So potentially, as John Vassos, I think, was saying, they might have brought seeds of life to Earth. So where are ETs or meteorites? Well, the surprising answer is they're everywhere. Back in the 1880s, ship dredged up the ocean floor, and in the ocean floor they found these tiny, tiny specks, round specks that turned out to be meteorites, or as they're called, micrometeorites. They're essentially in the dust around you, in your hair, in our food, on rooftops. And an interesting story, this Norwegian musician decided to look for them. I think he told a story that he was having breakfast outside and a tiny micrometeorite fell on the table. I'm not sure how true that is, but he spent 8 years searching the rooftops of Oslo, Norway for micrometeorites. And after ruling out everything that wasn't, he came up with things like these that are the width of your hair, that are micrometeorites. In fact, he wrote a book about that and explains how you yourself could find micrometeorites. But when we think of meteorites, we usually think of rocks, big rocks. And these are some of the biggest in the world. In fact, these guys here are the three biggest. The Cape York one, which was known for many thousands of years, and the Inuit used it to fashion weapons and tools. El Chaco from Argentina, the Campo de Shell, the Field of Heaven. It's a huge, huge field and a source of many tons of meteorites. I have one myself that's about the size of my fist that I call Darth Vader because it looks a bit like his helmet. And the largest one, the Hoba, was found in Namibia. Here it is excavated, 60 tons, the biggest ever found. And actually one of our RASC members visited that site when she went to a total eclipse in Namibia. So every year, amazingly, 40,000 tons of material falls to Earth. That's about 10 to 50 per day, but because the Earth is, say, 2/3 water and another 1/4 is not very accessible, maybe less than a dozen are potentially discoverable. And as it turns out of the 67,000 plus meteorites that have been found, just a small, tiny percentage have been witnessed, like the one on that first slide. You don't have to worry about a meteorite hitting you because your chances of being hit by one are like far less than being hit by lightning. The only well-documented case of someone being struck by one was poor Anna Hodges when a meteorite crashed through the roof of her house, bounced off a cabinet, off the wood floor, and hit her while she was sleeping on the couch, leaving that tremendous wound on her side. In another case in New York State, a meteorite punched through the trunk of this lady's Chevy Impala and was lying, she found it lying on the driveway, still slightly warm. So appropriate name for an Impala, being impaled.
I have a quick question, if you don't mind me asking, Bryon.
Sure.
Does getting hit by a meteor and or having your property hit by a meteor make it yours?
I'll talk about that later.
Okay.
They vary a lot around the world. I would say probably yes, but the reality is in some countries like Australia, most of Australia, that's not true.
Oh.
But in Canada it is, and in the US it is. Sorry, in Canada and the US, it's the landowner. So yes, it would be yours if you were on your land.
Right, if you're on public streets, then suddenly it becomes the government's.
Well, if it's on government land in the US, you need a permit to take them. And unless you're an amateur, you're just collecting a few, you can do that, then no problem.
Okay.
So the majority of meteorites are from the asteroid belt. Chris may have mentioned that. The remaining tiny percentage, and this is as of this weekend, are from the moon or from Mars, based on their chemical composition and the information we know about them. Where you actually find meteorites are in areas that they're easier to see, like Antarctica, I mentioned before, or Africa in the desert, or in North America in desert or ancient dried riverbeds. You may find them if you run out right away and they can easily locate a meteorite fall. In total, Canada's had, I believe, something like 70 meteorites that have fallen. So to identify meteorites, let's talk about the three basic types that there are. There's stone meteorites that account for the majority, about 94%. The ones I showed you later, earlier on, those giant ones, are all iron ones, but they only account for 5% of meteorites. They would tend to be the more ancient ones because they don't become unrecognizable over centuries and centuries of use, potentially. And then the rarest of all, and some exquisite ones, are stony irons that are about half and half. So the iron ones, they're mostly made of nickel iron that's cooled over millions of years. And because they've cooled over millions of years, internally, they form these long, beautiful iron crystals you see in that picture there that were taken from a slice and then etched to show the crystals. So obviously anything like that is not from Earth because you can't simulate millions of years in the lab. But the majority you'll find are stony meteorites, and they fall into two basic classes, chondrites and achondrites. They have iron as well, but far less, maybe 10, 25%. In the top here, you see a chondrite I have. You can see a fusion crust and you can see a cutaway. Here's the magnification. You can see these round spheres. They're called chondrules. And those are formed in the very early solar system, molten droplets in the cosmic material, and they coalesce into the rock. And you'll find them in chondrites. You won't see them in achondrites, which have some melting and they're reformed. Chondrites tend to be the older ones. They're very primitive. So they're interesting from that point of view. Achondrites, that includes the lunar and Martian meteorites. And then finally, the stony iron meteorites are about equal silicates and nickel iron. There's far fewer of them, possibly because they're more fragile and they don't make it to Earth. They're broken into two broad classes, pallasites and mesositerites, that are shown here. Pallasites in particular look really beautiful. I have a slice that it's a few centimeters across, and you can see the silicate here. It's a mineral called olivine. You shine a light through it and you get a lovely green, well, usually an amber color that looks quite beautiful, and then the shiny metal. Some of these are very, very valuable. So those are the three broad classes. They're broken up into many more subclasses. There's maybe about 50 right now, but that's a little too much detail. So now the next question, we want to identify them, and how do you tell a meteorite from a meteor wrong? Well, the simple chart is this. Is this rock a meteorite? No, it's not. That's usually the answer, but let's figure that out. Actually, one meteorite hunter that I met, for many years, he had on his shelf this rock, and he thought it was a meteorite, and others coming around did. He eventually found out it was an old beaten up brick. So they can fool even professionals. So how do you tell? If you take a meteorite rock, or one you think is a rock, it will tend to be heavier than an earth rock because of iron in it. Also, its shape, they're rarely round, they're not square or angular, but they're irregular, but not really weird shapes. They're more like the shapes you see here on the screen. Because they have iron, they're almost all magnetic. So a good earth magnet would be attracted to them. Color-wise, they may have a fusion crust, like the bottom corner here, if they're freshly fallen, and that's why scientists want to find them when they're freshly fallen if they can. But that gets lost with time. And they can have certain features on them that tell you they came from outer space. So the top right here, you can see the flow lines from the material ablating and vaporizing from the meteorite as it passes through the atmosphere. The next one shows an orientation of the direction of travel down to Earth. This one here in the bottom middle shows what they call thumbprints, little depressions where some more of the material ablated or melted off. In this iron meteorite here, you can see as it was rolling over in the atmosphere, the edges got melted, so it's smooth on the edges. Now, if we look inside, you'll find that meteorites, they're solid on the interior. If you have bubbles, then you've got slag or some other rock. You don't have a meteorite. So they're not porous, they're not layered with minerals like sedimentary rock, and most don't have crystals. The color is usually something like this if they're not metallic. If they're metallic, they're obviously silver. And you can see in this sample here from one I have, you can see the metallic specks of the nickel iron embedded in there. And if you look closely, you can see some lighter brown spots here. Those are the chondrules that formed in outer space billions of years ago. Stony irons are a mixture of the two. And this slice of one I have, you can see the iron, and you can also see the flashlight shining through the amber light color of the olivine. And finally, if you were to take your meteorite and scratch it on an unglazed ceramic tile, it would only leave a weak or a lightish gray streak. It wouldn't leave anything like these earth minerals, quite a bold color. So there you have it. You're an expert, but a lot of interest has happened lately on meteorites. So people want to find these, and labs have been overwhelmed. So for instance, Western Ontario, the university, has this quiz they want you to go through that goes through the sort of questions I just went through to determine whether you might have a meteorite or not. And if so, then you send them a photo, and then they'll go from there, maybe a sample or some arrangement to test it if it's deemed worthwhile doing. So if you want to collect them, maybe the adventurous way is the Indiana way. You go out like this guy, Jeff Notkin, a well-known meteorite hunter, and into the desert, and you look for them. But you want to get permission, as you were saying, and in some countries it can be difficult. I met and talked at length with one meteorite hunter who decided to go to Oman in the Arabian Peninsula during the Arab Spring. And he and his partner, they managed to collect many kilograms of lunar meteorites from his secret site, $200,000 worth. But someone ratted on them, and they were picked up by the police and thrown into an Arabian jail for 2 months because they were stealing archaeological treasures. Well, eventually their lawyer convinced the authorities that they were just finding old rocks, which is true, but they were also treasures, but they didn't tell them that. So they let them go, but without their $200,000 of lunar meteorites. So be careful where you might hunt for them. So I mentioned where you might go. There are these 2 links that NASA has where they tell you where meteorite finds are. I can give you a link later, Jenna.
So I will grab that from you, and for those watching on Zoom, I'll add it to the YouTube description once we have it.
Okay. So you want to pack for going to the desert. You want to have a good earth magnet, maybe on a long stick so you don't break your back bending down all the time. And any metal detectors, they can't be the beach ones finding coins on the beach. They have to be the ones that operate at higher frequencies that can penetrate that mineralized ground. And you want a good GPS to locate your find once you find something. You'll want a magnifying glass, a little field scale so you can weigh your find, and something to store them in until you get back to civilization. And then if you want, you could go to a place, I know before COVID, the ROCKIN used to have days when you could take your gems or minerals or would-be meteorites for them to assess and get an idea whether you actually had a meteorite or not. I'll just skip over this one, but some countries like Japan, Morocco, whoever finds it owns it. In other countries like Tunisia, it's the state. In Antarctica, I mentioned only governments go there. But the easy way of getting meteorites is you buy them from a reputable source. There's a lot sold on eBay or Kijiji, but I would try to find a reputable source if you could. One place I've gone a couple of times is to Tucson, which is a haven for a lot of meteorite people. And annually, late January into mid-February, they have a huge expo that's, I think the next time will be 2022 because of COVID. But out of the thousands of vendors that go there from all over the world, I counted over 24 that came from China, Russia, Malaysia, North America, Argentina, everywhere, selling meteorites. So it's a great place to pick them up or pick up other things like this museum special dinosaur that was worth $500,000, but you can also find things for $5, $10. So you want to decide what kind of meteorites you want to buy, because there's so many things you can get. Do you want a whole meteorite or a slice like these large iron meteorite slices? This one is from the meteor crater I mentioned. This is from Vesta, or you've got lunar and Martian ones in these display cases. They're all different prices. Obviously, things that are of more rarity will cost a lot more. Keep in mind that they all have metal in them, so they weigh a lot. So these top ones, whereas you could get a small one the size of a pebble for $50 to $100, these are all over 10, well, they're all over 30,000. This is 35,000 and this is $13,000. If there's a story behind them, like an observed fall, they'll be more expensive. So you can think of meteorites as the truest form of black gold. Depends on many categories. A lot of celebrities collect meteorites now. Elon Musk, for instance. This one here was purportedly part of quite a large, maybe almost a ton of meteorite that a Chinese hiker came upon in the mountain, and many times he rested on it when he was walking, and eventually he broke a piece off and sent it to a lab at the university, and he said, yeah, that's a meteorite. And so from that came this rare palisite. You can see the amber material in there and the metal. It never sold for the $2 million they asked, but it went back to the owners, whoever they were. This little tiny speck, just much smaller than a pebble, cost me $50 for this Mars rock. But here are some other meteorite, some ideas, the prices. So anything that's unclassified, it hasn't gone through, it's confirmed it's a meteorite, but it hasn't gone through the whole chemical and mass spectrometer analysis in a lab to determine what specific type. They'll be less expensive, like this one here. Here in the bottom right is my Darth Vader iron meteorite from Campo de Cielo, where El Chaco was from. This was not that expensive for a meteorite, but because of its weight, it was well over $100. Or you can spend a lot more for very valuable ones. Another thing you can collect are the results of impacts of meteorites. So very large meteorites will be in a crater or leave a crater, but massive ones, they really cause a wound on the Earth. So you'll get the Earth fused into these glass-like particles. Tektites are black kind of gravel glass nodules formed from the impact. Libyan glass from a meteorite impact millions of years ago in the Libyan desert. And moldavites from Czechoslovakia formed by another meteorite impact millions of years ago in Germany. Actually, some of these they make into jewelry. This one here with those flow lines is a museum level specimen, actually. So you can collect those. There's impact breccia, which is sort of some of the rubble from the meteorite impact fused together, or from the shock waves in the bedrock of Earth. You sometimes see these shatter cones, and you can see the shock wave imprinted on the Earth's surface. So those are all other things that you can collect, not just meteorites. Now, to take care of meteorites, it's a bit of a dog's breakfast because they don't like water, they don't like salts, and they don't like oxygen. So simple rules of thumb: keep them dry. Chris is holding up his iron meteorite. Keep them dry at constant temperature, maybe a sealed enclosure. I have some silica gel packets with little indicators on them that they use in rifle cases to keep the rifles clean and dry. You can buy them on Amazon. And if you're going to handle them with your fingers on the edges, or better still, with cotton gloves, so you don't get your bodily fluids on them, and that'll encourage further deterioration. Like I said, it's a bit of a dog's breakfast to deal with them. I bought one just in February, and already this iron meteorite is showing some signs of rust, even though I've been trying to keep it very carefully. So there's places like Paleobond that have kits for treating them and taking care of them. But it can be very difficult. And maybe I could take some questions now. There you have it. That's the end. In more ways than one.
Thank you so much, Bryon. And I will just quickly mention that Chris has to run. So thank you, Chris, for being here and giving us the rundown earlier on. And
my pleasure. Thank you guys for all of your attendees. Bryon, I appreciate you guesting. It was fantastic. Thank you.
So much cool information and so many cool stories. Chris, we'll see you in 2 weeks. And thanks again for being here. So,
all right, gang. Keep looking up.
Keep looking up. My favorite question so far, because, and I promise I've seen everyone else's questions too, but this is from Sicily. If a meteor sample is collected in space and brought to Earth, is it a meteor or is it a meteorite? Or is it something different because it hasn't passed through the atmosphere?
Well, technically, it would be a meteoroid.
Ooh. What?
Because
Hold on.
it would be a meteoroid, but essentially you're looking at a meteorite that hasn't gone through all of that ablation process.
Right, because it's a meteor on the ground, a meteorite in the atmosphere, and a meteoroid in space, right?
Right.
Right, okay. That's a great question, though. I really like that one. And there's another question from Stuart talking about, this is the key information that people are here for. In 2011, maybe, a meteor landed just north of Peterborough. Has anyone found meteorites from that event? Where are the coordinates? Does anyone suggest looking?
That I don't know, but actually I just lost my video. Let me see if I can get back.
Do you want to stop sharing your screen and then reshare it again once you find it? I don't know if that'll help.
I'm in my notes.
Oh no.
Okay. let me go here. So here's, can you see the meteorite falls slide?
We're seeing aliens from space collecting ETs, extraterrestrials.
Okay.
While you reshare, there have been a couple comments about Sudbury, and that it used to be, or it was a site of a meteor as well, and that's where all of the nickel and copper and those kinds of deposits came from. Now we can see Prescott, Arizona.
Sudbury was one of the biggest impact sites. The biggest one, I think, is in South Africa, in Southern Africa. But Sudbury is a huge basin and an ancient meteorite impact. Can you see this screen that says Prescott, Arizona?
Yes,
meteorite?
we can.
So that's one of the links I sent you, Jenna.
Perfect.
It lists meteorite falls so people can find them. This one here shows places around the world where meteorites have been found on that. And this here shows the size of meteorites that have fallen. So very large ones, not too many have been identified, but smaller ones, many of those.
Cool. I just sent some of those links out, and I did just get all those links from Bryon, so I will add all of them in the YouTube description.
Okay.
Wow.
Any other questions?
Janine was just wondering if you were willing to be contacted with further or to connect, but I may connect Janine. I may connect individually with Bryon's specific consent. Bryon, are you okay with that, or would you like to send your email address out into the world?
Well, give Denise my email and I can talk to her.
Sure. Okay, we'll do. And then so far, I don't think we have any other questions other than someone noted that apparently meteors are for sale on Amazon. So I'm not sure how reliable that is.
I'm sure they are. Amazon, eBay, Kijiji, you can certainly find them. One of the links that I gave you gives you a link to some websites where you can look at meteorites that are for sale. This one here, for instance, the Meteorite Exchange. Meteorites for sale here are listed.
There you go. I would put more trust in a site that is specifically for meteorites than I would in Amazon. Not to
one place I bought from is Jeff Notkin. He has the website Aerolite. That's in the links as well. AEROLITE. He's a reputable dealer and a meteorite hunter. And actually, pre-COVID, he did run expeditions to go hunting for meteorites for with people in the desert.
Oh, that's very cool. That wraps up all of our questions. And so on that note, I hope that some of you have been inspired to take up the new hobby of meteorite hunting, because I certainly want to now. I don't know if it's a great idea in the middle of COVID, but when we can travel again, I think that's something that I'll be taking up.
Jenna?
Yes.
I mentioned to you at the start that micrometeorites. So I gave a link to Larson's book and another link where he talks about how to find micrometeorites. I know someone in the club mentioned that they'd done that. So he recommends finding a flat roof, and you're finding meteorites that fell recently if you're looking for micro ones on a roof, preferably a vinyl roof. And of course, all of our flat roofs have asphalt. So what you do, you run over, you sweep them up, you run a magnet, you get an earth magnet in a plastic bag, run it over so it doesn't, so things stick to the plastic bag with the magnet inside. You drop that debris in another bag, and so on and so forth. You eliminate leaves and all that stuff. You might have to dry it out so there's particles that will stick. And you use ever smaller sieves because micrometeorites are only 0.2 to 0.4 millimeters in diameter.
Mm-hmm.
So you might have to buy a few different sieves and you sift through them. And eventually you'll get a few particles. Look at them under the microscope. If they're round and sort of look like what Larson has found, then you may well have a micrometeorite.
That's pretty cool.
So
might start doing that. Immediately what came to mind, there were a couple of chats about the meteor, the rock exhibits and the meteorite exhibits at the ROM. The first thing that came to mind, of course, being from Toronto, is the roof of the Science Centre, which has very limited access, obviously. But I wonder if we could convince them to go hunting. I know it's probably asphalt, but it's big roof, so you never know.
I don't think those groups would have the time or would do that. I mean, if there was a major meteorite fall and they wanted some help, maybe some people would go along. But
We'll see. Yeah, you're right, though.
Would make a business out of that sort of thing.
Well, thank you, everybody.
The ROM has one of the best collections in Canada, and there's a national collection. Montreal, the planetarium, has a nice collection. Some of the universities have interesting collections as well.
So hopefully we'll be able to start going back and seeing those soon. A lot of the places are still closed because of COVID, but certainly go out and check them out if you support your local museum and your local meteorite collection, and maybe try out buying some or finding them yourself.
Thank you.
Bryon, thank you so much for joining and for providing so much information. I think folks really enjoyed it. I'm really excited and inspired to go out and look for meteorites and to find out more about them. Thank you so much for sharing your knowledge, and we will see you again soon.
Okay, thank you.
Everybody who's here, I just wanted to let you know that we will be running another session December 1st and December 15th, and then we'll be taking a break for the holidays and coming back in January. And so we'll see you all then. Keep looking up and clear skies, everybody. Bye-bye. Take care.